All right, let's look at the homework 6.5, problem number 2. All right, so this is a bacterial population problem. All right, so let's look at that. All right, so it says that the bacteria, a population of bacteria divide, basically doubles every 20 minutes. All right, the initial population is 58 cells. All right, so it's actually easier to just do part B. So let's look at that. All right, so P of T, so population of this bacteria, is equal to, all right, initial population is 58 cells, so it's a 58. And it doubles every 20 minutes, so it's 3 times per hour, so it's a 3t, right? So that would be the function. So let's type it in. All right, so part B was 58, then it's a 2 to the 3t power, all right? All right, now we can look at part A. Remember that the relative growth rate is k value, and which is, since it's a relative growth, so growth rate, so it's a dp over dt over p, right? So we just have to take the derivative of this, so it's going to be 58, and then you have, so derivative of that is a natural log of 2, right? Then you have 2 raised to the 3t power, then multiply by derivative of 3t, so it's going to be 3, right? Then we have to divide that by p itself, so it's a 58 and 2 to the 3t, right? So you can cancel 58 and 58, 2 to the 3t, 2 to the 3t, so you will get 3 times natural log of 2. All right, so let's type that in. All right, so what we got was 3 times natural log of 2. All right. All right, so let's look at part C. All right, so we want to find the number of cells after 8 hours. So we're just looking for P of 8. All right, which is going to be 58 and 2 to the, right, 3 times 8, so 24. Right, so let's find this value using a calculator. All right, so it's a 58 times 2 to the 24. So it comes out to be, right, pretty big number. Let's see, 9. So let's type this guy in. All right, so this is an exact number. 973,078,528. Right, so that's that. Right, so we have that many cells after 8 hours. Right. All right, now let's look at the part D. All right, so part D, so we want to find the growth rate after 8 hours. Right, so in order to find that, it's actually, since relative rate of growth is 3 natural log of 2, remember that the dp over dt is equal to k times p. So k is 3 natural log of 2 and times p, right? So which means that if you are looking for p prime of 8, right, then this is exactly the same thing as 3 natural log of 2 times P of 3, right? P of 3 is just the answer from part C, so we just have to multiply by 3 natural log of 2, right? So we're going to just say, so we're going to take the answer from the previous one and multiply by 3 natural log of 2, right? So we're going to get this. All right, then they want to round your answer to 3 decimal places. And it looks like, let's see, 1, 2, 3, 1, 2, 3, 1, 2, 3. So it's a 2 billion. So 3 decimal places, so 2.023. All right, so let's type that in. It's a 2.023. All right, so billion cells per hour. All right. Now, let's look at the part E, right? So when will the population reach 20,000 cells, right? So we don't know the T yet, so we just have to set the P of T, which was 58 2 to the 3T. Now we just need to set this to 20,000 cells, all right? Then all you really have to do is we're going to just divide through by 58. So we would have 2 to the 3t power is equal to 20,000 divided by 58. Right? Then we can take the natural log of both sides. Right? Then we can move 3t in front of the natural log of 2, and we would get 3t natural log of 2 is equal to natural log of I'm just 20,000. I'm going to just write that down over 58. Then, to isolate t, we just have to divide through by 3 natural log of 2, right? So t is going to be equal to, so natural log of 20,000 divided by 58 divided by 3 natural log of 2, right? So this comes out to be, right, so it's a natural log of 20,000, right, divide by 58, and then divide by, parentheses, 3 natural log of 2. Right, so let's compute that. Right, so it's going to take about let's see, round to answer 2 decimal places, 2.81. Right, so it's a 2.81. Right, so let's type it in. Right, 2.81. All right, so let's submit for testing. All right, it came back, and looks like we got part A correctly, part B correctly, C, D, E correctly. All right, that's it. I hope that this was clear.